Welcome. You have seen the concepts up there about radioactivity. And then in radioactivity, we have the activity of a source, which is simply the rate of disintegration per second. Now I want us to concentrate on the activity of a source and its units. It can be measured using different units, but I want us right now to concentrate on the Curie, because the question that we want to answer is, we want to show that 1 Curie is equal to 3.7 times 10 power 10 disintegrations per second. Now we go to the solution. So we cannot answer this question until we know the definition of 1 Curie. I try to write the definition as 1 Curie is approximately the amount of radioactivity produced by 1 gram of radium-226. Still, we cannot be able to calculate this question unless we have a constant, which is the activity, which is the half-life of radium-226. So the half-life is 1,600 years, and on my calculator I've seen that it's approximately 5.046 times 10 power 10 seconds. So let's go now to the solution. First, we have to remember that activity of a source is the same as the number of active atoms times the decay constant, whereas the decay constant is the same as ln2 divided by the half-life of that substance. So meaning that for us to be able to calculate the activity of 1 gram of radium-226, then we must be able to use this formula, for which we already have the ln2 and the half-life. Therefore, we are only looking for the number of atoms that are present in 1 gram of radium-226. So let's find that. We must also remember this concept that in the atomic mass, which is 226 grams of radium, contains the Avogadro's number, which is 6.02 times 10 to the power 23 atoms. So this means that in 1 gram only, we shall have 6.02 times 10 to the power 23 atoms, obviously divided by 226. So this means that in 1 gram of radium-226, we have this figure as the number of atoms. Therefore, we can now calculate that 1 Curie, which is the same as the activity for 1 gram of radium-226, then this is going to be the number, which is 6.02 times 10 to the power 23 divided by 226. These are atoms, divided by, multiplied by ln2 divided by the half-life, which is 5.046 times 10 to the power 10. Using your calculator, trust me, you must get 3.65 times 10 to the power 10 disintegrations per second.